Let us find the nature and the location and nature of the critical points for this function. Now, from our formula sheet, we know that we're going to have to find the first partial derivatives, that with respect to x and also with respect to y, equate each to 0 and solve to find the locations of the critical points. Then after that we find the second partial derivatives and carry out the d test. So let's see. Here we're going to find fx. We treat x as the variable here and y as a constant. Alright? So what we're going to have is y squared minus 2612x. Okay, that's what we have. And then fy now is equal to, so it's going to be 2xy minus 3236y. Alright, so we have that. Now let's equate each of them to 0. We have y squared minus 12x is equal to 0. Good. We also have 2xy minus 6y equals 0. Minus 6y equals 0. Now, here, if we transpose this to make x the subject, we're going to have y squared is equal to 12x. So x will be y squared divided by 12. Alright? And then, here, we could substitute x over here. So we have 2 times y squared divided by 12 minus 6y equals 0. So that's what we have. Now, after that, let's do some simplification. 2 into 2, 1, 2 into 12, 6. So I have y squared over 6. Oh, there was a y. I left off this y here. Times y minus 6y equals 0. So we have that. If we multiply throughout by 6, we have, and we could combine the y squared and the y. Y squared by y is y cubed. Y cubed minus 6. When we multiply by 6, this cancels. When we multiply by 6, we have 36y equals, and then that will be equal to 0. Now, let's factor out y. Y times y squared minus 36 equals 0. We know this is the difference of two squares. So remember how to factorize the difference of two squares. We're going to have y, and then we have y minus square root of 36 is 6. Y plus 6 equals 0. So, there are three possible values of y here. Y is going to be 0, y is going to be 6, y is going to be negative 6. Alright? So, those are the three possible values of y. Now, what happens when y equals, what happens when y equals 0? What happens to x when y is equal to 0? Remember, we have our z, f of xy, sometimes called z. We are looking at plotting the points X, Y, Z. No. Z. What was Z equal to again? Here. Z was x y squared minus 6x squared. That is xy squared minus 6x squared minus 3y squared. And at the same time, x is y squared over 12. X is equal to y squared over 12. Let me rewrite that. X equals y squared over 12. Now, when y is equal to 0, x is equal to 0 squared over 12, which is 0. And what is z? Z is equal to x and 0. Well, x is 0, y is 0. So it's 0 times 0 squared minus 6 times 0 squared minus 3 times 0 squared. So z is equal to 0. So we have one point at 0, 0, 0. One of the critical points is located at 0, 0, 0. Alright? Now, when y is equal to 6, remember one of them was 6, x is equal to 6 squared over 12, which is 36 over 12, which is 3. Right? So we have x equals 6, y equals 3. What is z? So it is xy squared, which is 3 times 6 squared, minus 6x squared, which is 6 times 3 squared, minus 3y squared, which is 3 by 6 squared. Right? And then you work that out to find out what that is. Let's draw for our calculator to see what that could be. 3 times 6 squared is 36, minus 6 times 3 squared is 9, minus 3 times 36 equal, we have negative 54. So another point is located at x equals 3, y equals 6, z equals negative 54. Now, when y is equal to negative 6, what is x? X was what again? Y squared over 12. So y squared over 12, which is negative 6 squared over 12. What? This is amounts to the same 3. Right? Now, we found out, or we'll find out that what we have is z is equal to xy squared, in this case 3 times negative 6 squared, minus 6x squared, so it's minus 6 times 3 squared, minus 3y squared, so it's minus 3 times negative 6 squared, equals. So let's work that out and see what we get. So we have 3 times 36 minus 6 times 9. minus 3 times, well, it amounts to 3 times 36 again. Alright, 3 times 36 equals. So, what we have there is, I was expecting it to be the same as before. Let's check again. 3 times, oh, the 6 didn't go on. When I press 6, it didn't go on here. 3 times 36 minus 6 times 3 is 9. 6 times 9 minus 3 by 36 equal. Negative 54 again. Negative 54. So the other point is located at 3, 6, negative 54. Well, it's really 2 points. It's a repeated point there. Alright? Now, what we want to do, well, first we know where the stationary points are located. Let us now find the nature of the stationary points. Right? Here, what we're going to have to do is find fxx and fyy and fxy. So here now, want to find out what is fxx, what is fyy, and what is fxy. We could also find fyx to reassure ourselves. So fxx. Fx is y squared minus 12x. So we're going to differentiate y squared minus 12x. What we would get is negative 12. Negative 12. What about fyy? Fy was 2x minus y, 2xy minus 6y. When you differentiate this with respect to y, we're going to get 2x minus 6. Right. So that is our fyy. And then we're going to find out what is our fxy. What we have is our fx. When you differentiate fx with respect to y, we're going to get 2y. This will give us 2y. What about xx? Or xy. If we differentiate the fx with respect to y, this was x with respect to y. This is y with respect to x. Here we're treating x as the variable and y as the, what we had, fxy. We did add x and we differentiate with respect to y. Now let's try fyx. This is fy differentiated with respect to x. So x is a variable. So we get 2y again. Alright. So that's what we got. Now, let us find out what happens from the D test. Right? We have D equals it's going to be fxx AB. So fxx AB going to be negative 12 times fyy AB. 2x minus 6, we're going to substitute it after. Right? Minus fxy squared. So in this case, we have 2y squared. Now the AB will be the values that we got first. What were the values? So here, when we solved and got these values, right? Let's simplify this before we substitute. So d equals negative 12 times 2, that's negative 24x. Then we have 12, 6, 72. It's going to be a positive 72, right? Minus, then we have 2y squared. 2 squared is 4, y squared is just y squared, all right? So, that's what we have. Now, one of the points, one of the locations was 0, 0, 0. So, we're going to test this at 0, 0, 0. What happened at 0, 0, 0? D is equal to negative 24 times the value of x, remember, is x, y, z. Value of x is 0 plus 72 minus 4 times y, the value of y is 0. So it's minus 4 times 0. But this is 0, so what you have is a 72. Right? So make sure you follow what happened there. Alright? Now, what happened at the other point? Let's see, other point again. 3, 6, negative 54. And it was repeated at 3, 6, negative 54. Right? I want to substitute the values and see what we get. Now at this point, d will be equal to negative 24 times x. And in this case, x is 3. Right? Plus 72 minus, and then 4 times y squared. Y is 6. So it's 4 times 6 squared. So let's just use our calculator and work it out. Waiting for it. Alright. So what we have is negative 24 times 3. Alright, we get that. Plus 72. That will be 0. Then minus 4 times 6, 36 equals. And we get negative 144. Right, for that. I'm sure you follow. Right? So, in that case, these are the values d. Now, here, d, let's look back at our formula sheet. If f x x a b, if d is greater than 0, yeah, d is greater than 0 at 0, 0, 0. What about fx ab? fxx ab. That means we look at fxx and substitute the values in it. fxx was negative 12. So fxx is less than 0. Alright, so we have d greater than 0 and fxx less than 0. So we have a maximum point. Right? So right here we have maximum points. You see that? It follows from the formula sheet. Right? Now, here at 3, 6, negative 24, d is negative 144. So let's see now. 4. When d is less than 0, we have a saddle point. So here we have a saddle point.